Okay, now then, let's start our workshop today. Okay, so we'll focus on the use of GeoGebra, and this is a beginning workshop. So I try to include some basic ideas about the use of GeoGebra. Right? Feel free to ask me any questions if you think that you want me to elaborate. Okay. Now, first of all, I put most of the material in my website, so you can see the URL here. Okay, the red one. This is my URL. Okay. So I assume you have the notebook computer, right? So you can get online and you can access my website, and then you can see the page containing the examples and the links. Okay? And in fact, this is my website also holding some other materials to share with teachers as well, right? So you can visit my site anytime you like. Do you get it?
Yes.
Okay. Now, okay, and then inside this one, you can find the tab here using tablet. Okay. I include most of the materials about use of technology here with this page or using tablets. Just because recently we have more demands about the use of tablets device in the classroom. Okay, and that's why I simply collect most of the suggestions about the use of technological tools in this page, and the title is for the use of tablets. For example, iPads or other device that you will find in the classroom by the student. Okay? But the main point is still about using the tools or the software or the applets. Okay? And then we include different examples as well. So if you scroll down, you will find a list of items, quite a long list here, but not very updated. Okay? Don't rely on this. If you look for something very new, or in case and you click on some other links below, you will find it may not be so updated. But the one above should be updated. Okay, so the first line is about GeoGebra. You can see that. Okay, it is basically hosted in the GeoGebra 2. The website itself is called GeoGebra 2, just like YouTube actually. Okay, you use the link like YouTube. Okay, but the tool is GeoGebra, but the website is called GeoGebra 2. Okay, so you can click on GeoGebra 2 to find the page. Okay. Now you better keep my web page open first, okay? Because I will show you the other links later. But first of all, you can come to the GeoGebra Tube website. Okay, so that is the front page of the software together with the resources. Now you can see here I have logged in with my account. Okay, so if you haven't registered, of course you will not be able to open such a page. Okay, but you can see me because I have already logged. I've registered there, right, as a teacher, so I have an account. But if you have no account, then I think you will just see this general information on the page. Do you agree? I think more or less the same. Okay. Right. Now I encourage you to create an account there. Have you done so? Anyone? Have you done your account? The rest can try to do it. Okay. I think it's very convenient. And also can help you to collect or get a lot of different materials right there with the teacher's account. Okay. Now, so this page basically serves the purpose of sharing and hosting resources. So one basic tab is called the classroom resources. Can you see that? So you will see a very big pool of examples or materials that have been created by other users. Okay? And then usually they are shared here directly with teachers. Okay? So this is a platform for sharing, hosting many material. Now at the same time, you can create your own materials. Okay? So that's why they have a tab called this one, Start Graphing, but not just graphing, in fact. Okay? If you scroll down a little bit, then you will see all the apps available. Okay, so the first one, maybe the more popular one, will be graphing calculator. Okay, because usually that is the part quite often used in the school. But don't forget that it also contains other major tools as well. They call it apps here. For example, geometry is also the one that I like to use quite often. Okay, and then 3D graphing calculator, or even 3D geometry. Okay, so this is the tool for the 3D tools, okay, 3D materials, not just calculations, okay, but also geometry. CAS, you know what CAS means?
Computer algebra solver.
Yes, computer algebra system or computer algebra software. Okay, that means they will basically handle symbolic calculation. Right? That means even symbolic differentiation or integration. I say symbolic, not numerical. Right? So you can simply plug in a formula and and then ask them to integrate, and then it gives you also another formula, right, as a result, right, as a function, as an answer. Okay, the scientific calculator is the other direction, right? Going back to be something more simple, okay, and primitive. And then another one I also like to highlight is that this is called the GeoGebra Classic. Okay, GeoGebra Classic is actually the earlier platform. In fact, I personally like this one more than the new one. Okay, and also a lot of examples have been done by the GeoGebra Classic. Okay, so sometimes you may see that the products are made by the classic versions, which looks a little bit different from the latest version. Okay, so maybe you have to bear in mind. But one thing useful about the classic version is that one classic version combines all the different tools together. That means geometry, algebras are put together under one classic bundle. Okay? But I don't know why now the authors like to separate them. Actually, I'm not too sure. Right? I personally prefer the classic actually, right? Combining all the things together. And on the other hand, you can also download, okay, through the App Store, the usual, or even for version in your in the computer. Right? For example, in my computer, I have this. I think it's not just this one, but at least I have one version. Right? At least one version here in my computer. Sometimes, if you're making complicated files, I think the desktop version should be more useful. Okay? But if you are just trying something simple, maybe the web version is good enough. Okay? So I'll just give you some idea. In fact, even if you're using iPad, you can still open that and use that. Okay? But may not be so convenient as desktop, because we can still manipulate quite a lot. Any question up to this part, first of all? Now, then before I start using something to create, okay, some materials, I will just show you directly the resources. Is it okay? All right. So you can have a look of different things that people have tried and done. All right. Now you click on Classroom Resources, then you can already see a lot of materials, right, that have been done by other people. Okay. So there are some. This is a very small collection. I think they will keep updating every day. Okay. So it's just the latest one or the newest one. You can also check the category as well. You may have your favorites if you have already logged in, okay? Or you can see this tab is called Mine because I have logged in here. Right? That's why this shows my own materials or my collection. Now it doesn't mean that all these things are done by me. I can go to find materials made by others and then save a copy in my account here. Okay, so it can be something that you collect from others, right? So I encourage you to register. That's why, so that you can start building up your own collection and then try to gather more materials if you like. Okay. Now later on I will show you this workshop materials. Right? So this is one collection. There's already include different examples. Okay. I just open quickly. I will show you what it is inside. Okay. So inside each of this collection, you can see individual GeoGebra file. So for example, now this page contains one GeoGebra file. Okay. But it's not just one. You can see a lot here in one collection. Okay. These collections are called GeoGebraBooks. They call it books. But basically, that means a folder holding many files together. It looks like a book. Okay. So each page contains usually one GeoGebra file. So this is one GeoGebra file, right? So it is dynamic, so you can play with it in any way you like, or continues to use the tools provided to add on other parts or doing other exploration as well. Okay? Now, so later on, if you go back to the pages like this, you will find many examples throughout the website, okay, or throughout the platform. Okay. And some of these can be very complicated. Okay, I'll just let you know. If it's totally new to you, don't expect yourself to be able to make many of these files, okay? Because it may take quite a lot of techniques or skills of doing it, right? But you can start collecting it, all right? You can check which one is useful, and then you can put it in your own folder, and then use it anytime you like, okay? It is fine. But later on, you will start creating something on your own, then you can start to learn more about the technique or skill, But bear in mind, some of them may require more complicated skill. Right? Even some may say that nowadays the file seems to be made like using complicated programming. Okay? But it's not totally true, in fact. Okay? It really involves a lot of complicated skills, okay? But not exactly like those using computer programs. Okay? But anyway, it's more or less the same. Okay? As a new user, don't expect yourself to be able to create too many things. Okay? So any questions about this one? Now then go back to the pages again. That means now bear in mind, once you register, then you can go to resources. Okay? You can start finding any interesting resources you like. I just click on something arbitrarily. Okay? For example, this one, anything you like, you just click inside, and then you can save it. Okay? So you can share it, add your favorite, or create a copy this activity. Then you have another version in your own account. Okay? Then you can group them together in different ways you like. Okay? So you can do this later. Okay? I'll just show you how to find them. Or you can go to the tab called People. Okay? On the left, can you see this one? Okay? Then you can see a lot of different users. Right? Some of them could be maybe very key users. That means a lot of materials inside. But of course, at the beginning, you may not know too much. Okay? You just try to find them by chance. So it's once again, it looks like the social media platform. Okay? So you can start follow people. Okay? You just click for it. Now, for example, for me, I'm following this group of people. Okay? I will show you some suggestions later. Okay? And then someone's also following me, something like that. Okay? So it's like a social platform. Understand? But once you create this community, then you know how to find more and more materials, right? Or more materials are appropriate or relevant to your context. Understand? Okay. So let me show you how to find some material first. Can you see my website again? Can you see this page? So you can follow the first line in the bracket here. I say see my notes. Okay. So you can open my Evernote files. This is my Evernote file. So here I show you a bit more links related to GeoGebra. Can you open this one? Right. So you can see more links. Particularly, some are the local materials. Okay, we have a community called GeoGebra Institute of Hong Kong. In fact, okay, I can enlarge a little bit. Can you see this one? Okay. Yeah. So the GeoGebra is an international tool. So it is developed at the beginning, very beginning, it's developed in Austria. Okay? But later on, now it is more or less worldwide. Okay? I can't say that where it's based. Okay? You can see that it is internationally, many teachers use it, right? Including Asia, actually. Okay? So not just all the materials are in English. Okay? And then, but in Hong Kong, then we have one organization, you can say that, right? That we try to put together teachers that are interested in the use of GeoGebra. So you can find also suggestions on this website. Okay? So I also contribute to this as well. Okay? And then you further down, you go down. Then so this one is actually projects in Hong Kong. Okay? Then led by one of the teachers, the key members of the institute. But he also worked quite a lot in his own school, right, to produce a set of very well organized, well-developed material. And many teachers in Hong Kong now use it. Okay? So this is also a very good place for you to start, finding material that could be useful. It's more relevant to the Hong Kong curriculum. So I don't open it now. You can visit it later. Okay? So these are the website. And this view, you can see that looks very similar. Okay, that's why I say that they are different, but they look still similar to each other. Okay, now if you scroll down, then you see what I call the GeoGebra books, right? So each book is actually collections of different materials inside the GeoGebra platform, and then I list some of my books here. Then some collection. I think the first one already showed you a variety of examples, right? I call them workshop samples. Already include a variety of different examples. The later one will be more specific in different areas. Right? You can find these links. And also, the GeoGebra Institute of Hong Kong also has an account inside the GeoGebra platform. Okay? And then this part is more related to primary school teachers. Okay? So including some Chinese materials as well. Okay? But not too updated. If I have time to update it, maybe I will modify it later. And any more? Let me see. It's more or less the same. Yeah. And this is my personal account inside the GeoGebra too. Okay. So if you click on this, then you can see my material and files. And then further down, you see two books. Okay. The first one is in our Hong Kong U library. You can see it is an e-book. Okay. So you click on this and then find this e-book. It's called Mathematical Modeling Application with GeoGebra. Right? It contains a lot of examples, actually. Right? Although the title is about modeling, of course it's really about modeling, but modeling is also a very broad area. Right? It may include a lot of different kinds of materials to be used with GeoGebra inside the classroom. So I suggest this one, right, which is very good reading. Okay? And another one, also available in Hong Kong bookstore now, okay, is in Chinese. It's written by a teacher in Taiwan. Okay, so you can follow the link to the Google Books. Okay, you can access. I also bring it today. I think this is the one. So this is the Chinese one. Okay, that you can find it in Hong Kong bookstore perhaps. And also the link here is this teacher's account in the GeoGebra too. Okay, so you directly go to this one. Now, by the way, I also picked another one quite some time ago from mainland China. Not the same tool, but it's similar. Okay. So it is written by another professor in China, Zhang Jingzhou. Do you know it? Do you know this professor?
Yeah. I know.
Right? So have you used this tool?
Professor in my university.
Oh, okay, very good. Okay. So are you familiar with the tool?
Yeah.
Right, so it's dynamic geometry, right? Originally, it is more about geometry. Right? Have you used it?
Our teacher suggested us to use this, but we find it difficult.
How about the others? Have you heard about that? Maybe you can pass around and have a look. I just say that this is a similar kind of tool, which have been developed in China for many years, actually, right? So I just let you know that this is not totally new, okay? I mean, same kind of tool can be developed in different places, okay? And also in mainland China, that is the one I think is more, should be the most famous one, I think, in China. And I also learned a lot from that professor as well, through his material. Even though you may be sometimes using different software, but the teaching ideas behind them can be similar or related. Okay? So or if you have any experience, you can share with me later, right? In case you have also used it before, or maybe in your own study or in your teaching, you can also let me know. Okay? So I just tell you the similar things in different places or in different tools. Okay, so you can have a try to assess this one. Okay, I can show you briefly. This is my version. Okay, this is my version of the one in English. This is written from a Swedish, I think it's Swedish author. So including a lot of examples. Can you see that? So a lot of quite detailed, okay, suggestions on steps to go through. Okay, so you can see these examples here. And if you look at the content, okay, so the first few chapters are different kind of problems. The first few chapters, okay, grouping it under different categories like linear models, non-linear, empirical models, something like this. Okay, so different kinds of models, or with calculus, and then differential equation even, okay, or geometric models, or different kinds of models. Discrete models are these in another areas in mathematics, right, that you can still also use in GeoGebra. Now, and then starting from chapter 9, it's called modeling in the classroom, right? So that will be more about teaching, right? Teaching ideas, right? So it's not simply the technique, right, or the procedures of using the software. Okay? And also assessing modeling, right? So these are also related to teaching and learning, right? Assessing models here means, I think, assessing the students' work, okay? So that means in case later on, particularly in the IB curriculum, you may also further encourage your student to use the tool for different explorations, okay? And perhaps you also need this kind of knowledge or understanding as well, right? So these are good starting point for you to try. And this is the Chinese one. Okay? This one is more about the technique, okay? Not too much about teaching ideas. So, but it's also very informative, okay? So you can see go through it quite a lot of different good examples. But bear in mind, still the books are mainly using the older version, okay? That's why I say the classic one is basically this platform, okay? because the one you see now on the web is very, very recent one. Okay? But for most of the books or the written material that you come across, basically I think are referring to the classic version. Okay? I hope that you won't have too much difficulty in transferring from one to another. Okay? Try your best, or let me know if you have any questions about it. So, any questions before I move on? Do you have any questions before I move on? Okay. Now then, can you go back to the workshop sample? Can you open this link? Right? Then you'll see more directly my examples. Okay. So if you click on the link, then you can see one of the GeoGebra books I have. Okay, this is one of the GeoGebra books. So you can see the tab here, including different chapters. And each chapters contain a number of files. Okay, that's why they put together like a book. In fact, later on, if you have enough materials to organize, right, then you can actually consider putting it in this form, like a box with chapters. Particularly, you may try to associate with the curriculum materials or the textbook materials, right? You can put it in the relevant chapter so that you can find it more easily. Now, for me, I demonstrate different kind of files, right, for you to have a look. And the links in the first page show you the previous links again, together with some other books, okay, which also contain different specific types of material. And for this authors, okay, these are persons that you may try to follow. Okay, so the first few, the starting point I recommend. Okay, these are more productive and also very active users. Okay, and Anthony Orr and Alex Chicks are in Hong Kong. Okay, so they are Hong Kong educators and teachers. So you can follow the link to find a lot of useful materials made by them. And later on, maybe you can also find your own. Okay, I mean some other users that you prefer. All right, so these are the contents of my book. All right, now you can feel free to explore. You don't have to follow my demonstration step by step. Okay, so you can feel free to open any page you like and then try with each other. Now, the first chapter, can you follow me? This is what I call a chapter, right? Simple manipulation. So this is one chapter, and within it, I have different files. Okay, this part shows a little bit simpler files. Okay. Simpler in the sense that you won't see too many complicated manipulation. That's why I say simple manipulation, right? The student can do some very simple manipulation. Particularly, I quite encourage or emphasize the student's actions on screen, not simply the teacher's demonstration, right? So in case the student can move quickly or in a simpler way to experience the mathematical objects and ideas, then that will be a good starting point, right, for the learning and the teaching. And the later ones, some of them can be more complicated, okay? And the second section about geometry, can you see this? So this is some of my favorite geometry problems, right? Some are quite simple, some are a bit more complicated, right? But they are all related geometry problems. So give you a list of ideas, right? So to what to work on. For example, the first one is one of quite typical geometry problems, okay? Maybe now you can enlarge it. Can you see this tab on the lower right? Okay, and you click it, then it will be enlarged, right? Then you can only see this file now. Okay, now you can see two circles. All right, so this can be varied. You can change the size, and you can see line GH on one of the circles. Okay, at the same time you have another. Let me see. Oh, so. I think you construct this way, right? The G is joining the one of the intersection, and H is joining another intersection, and they are extended to cut the circle, another circle in another 2 points, right? So that you will result in another red line AJ. Okay. Actually, the question, usually the textbook question will be to prove that this AJ, so IJ, okay, is parallel to GH, and the red lines are parallel. Okay. Can you understand the construction? Okay.
Yeah.
You start with 2 circles, and then we have the intersection. Okay, and then now so you see that some of the points are movable. Okay, so G, H are movable. Right, there are 3 points on the circle, but I and J are not movable. Right, because they are the result of the constructions. Understand? Right? But you can see that ij looks always parallel, right, to gh. Okay? Then you can start to discuss with the student how to prove it. This can be one. Actually, I think this is a rather typical textbook problems. Okay? But if you put in a dynamic version, then of course the experience can be different, quite different from what you usually see in the textbook. Right? In fact, I like this one very much because it can be changed in many different ways. If I change it this way, the relation is still the same. Okay? It's still maintained. Okay? But the written proof may be different, right? Because you may adjust a little bit the writing of the proof in this case. Okay? Any other special condition? We can also move the circles around. You see that the condition is still the same. Okay? Or even when let's say, when the lines become a tangent. Right? So all these are different special conditions or special situations. Okay? But based on one construction, basically. If you start with one construction, then you have all these problems at the same time. Right?
Even G and H are the same point. They're still parallel.
Yes, G and H, right?
Yeah, at the same point.
Oh yeah.
One
It still works.
Yes.
Okay? So you can play around, and then so you can see the richness of this problem when you present it in a dynamic version, okay? Which is very different from the textbook version. Okay? So maybe you can try to learn how to use it or create this later. Okay? But now you know what does it mean by dynamic, right? Dynamic files. Okay? In terms of geometry, you can see the structures like that. Now in this file, I keep the two bars. Okay? So these are the two bars for you to directly create geometric objects. Okay? But in some other files, sometimes you remove the two bars to make the file simpler. All right? So it depends. You can choose to keep the two parts or hide it. Okay? When you try to present it to the student. Of course, I keep the two bar here for some reason. Okay? Because you may want to talk about the proof. Right? And then in case the student have any suggestion, perhaps you can try to do some further construction lines there. Can you see that I already add one line in the very intuitive way, right? I just choose the segment. This is the toolbar, right? You can choose any one of this construction tools, and then of course it may take time to understand how they work, okay? But some of them may be more intuitive, right? For example, segment here simply means just joining 2 points, you get a segment, right? But yes.
So if we have an iPad and download the app on the tablet,
yes,
can it work on the scratch with the Apple Pencil?
Yes, you can. Right. So say for in some classroom, you remember my page. Okay, I say using tablets. Okay, because most of this material can be used with tablets. That means the iPad. Okay? So you can open, of course, through the browser usually. Okay? You can open it and then use the iPad to do what you say, even using a pencil to have some brief drawing. Let me see where I have this one. Yes, this is the pen.
Oh.
Right? So for you to do some scribble if you like. But for today, I asked you to bring the computer because it's not easy to make things with the tablets. Right? It can only mostly allow you to do some simple manipulation, right? But not that easy for you to create files from here. That's why it may not be so appropriate for this workshop. Right? But in general, in the classroom, using a tablet is good enough already. So, so you understand why these lines may work, all right? I think you can even create an angle. So this is the angle tool. Can you see this? So if I mark it GH, oh, so I make the wrong way. So now I make the reverse angle. Maybe I undo it, okay? I try the other direction. FHG, okay, then this works. So this is one of the angle. Right? So you can see the size of the angle. This is already shown. And then you can now relay it to another angle, GEF. Okay? So of course you can ask the student what should be the relation between these two angles. Right? And then the third angle that could be related will be this one. Also in the wrong direction again. So no worry, just undo it. Or maybe I adjust a little bit because I think that's it. Yeah. I think it overlaps with another point as well. So that's what I'm showing. So do you know what I'm doing? Not this angle. Probably this one. Yeah, all right? Will these three angles be useful to demonstrate or to explain why these lines are parallel? Okay? So you can add any constructions instantaneously in the classroom, particularly if the student can have any suggestions, right? Then you can try to follow them or make the tools you like. Right? So you can also show how the relation still works. Okay? If you're moving it around or changing it, something like this. Now you can also change the color. So if you click on any objects, there are many ways to do things in the platform because they allow different kind of shortcuts actually. Okay. So sometimes I may demonstrate one way, sometimes I may demonstrate another way. Okay. Now I'm showing you how to modify the objects. Right? For example, you have the angle here. If you don't like the angle, don't like the color to be the same, then you can just change the color. So this will help you to identify more clearly the color. And so that means this part will give you the tool to modify the objects or the appearance of the objects. Okay? Depends on which one you click. For example, this one is the line segment. Okay? Then I can turn it into dotted line, or even make it thicker if you like. Right? So the appearance will change. Right? So later on, when you click on any objects, you can check what things you can change, or even open up another box for more detailed adjustment. Okay? So you can. This is in the previous version, it's called the property dialog box, but now I don't know what I may not know the current names for this actually. It may be just called setting, right? The adjustment of the setting. Okay, so is it helpful for you to understand briefly about the interface? Because still a lot of tools you may not know too much now. Okay, just give you some ideas about the interface here. All right, if you finish this one, you just I think resume the original screen. Then you go back to this one. Now, bear in mind this. Now I have added something to the file, but this is not saved. Okay. Once you leave this page, it will be refreshed. Okay, and come back again. Right. So these are not saved unless you try some means. You can check whether you're allowed to save. For example, I can save a copy here. Okay, or even capture the picture perhaps. Going to produce something like this. Okay? Just to let you know. If you want to keep this picture or keep this particular sample, because you may already move around the points and change the arrangements, okay? And then you may have to save it if you want to keep it. Otherwise, you just leave it instead. It's okay. So now these are other examples in my geometry files, geometry sections. Okay, some of these may be a little bit more complicated to draw. You can come back to this one later if you like. Okay, the next sections will be 3D, three-dimensional objects. So you can also create quite a lot of different three-dimensional objects here. For example, this one cube in. This one is called a cube in a dodecahedron. Okay, that will be rather complicated. Okay? So you can see a dodecahedron. Okay, but I also put a cube inside it. Okay? So actually, you can cover it if you try to put back the removing part. Then you can see the complete dodecahedron. Okay? But if I take it away, the outer part, and you will see a cube inside. Right? Now, this kind of file can be made by the GeoGebra as well. Right? So the previous version is about 2D. Right? But later on, you can also open the 3D window and then make some 3D files like this as well. But of course, they will be more complicated, right? And you need more time to do it. So, but it's basically the same tools. Right? So when I close it, remember the right button, right? You can enlarge it or just resume, right, the original screen. And then some other 3D files. Okay? These are different 3D files. For example, the last one is about a cone. Okay? So this one also a bit complicated as well. Right? So this is basically a circular piece of paper. Right? So imagine that you can cut a sector, right, for a particular angle. Okay? So you can check the angle here. For example, this one is 240. Okay? And on the other hand, you can see how it can be used to make a cone of a particular height. Okay? So the question is about how you can tell the space circumference and height based on the dimension of this circular piece of paper. Okay? So on one hand, this is the 2D geometry file, and then the other one is the 3D geometry file, but they are put together, right? So in the classic version, you can have more than one screen, okay, put together. That's why I like the classic versions, okay? But in the latest version, they have to separate that, right, one by one. So sometimes I still go back to the classic version. Actually, the upper panel is also another version, right? It's another screen, show you the value, right, the data, right? So if you take away R, then you can ask the student to make a guess. Based on this numerical value, if L is the, let me see. I think L is this radius, OA. Then what is R in this case? R is the radius of the cone here. So you can see this. So you can check it. Okay? So you can hide and show the numerical values. Okay? You may have to round off a little bit, or maybe. Okay, also not so accurate. Or you can also change the length here. If you change it to 10, then the base radius is also changed as well. Okay? Okay, so do you see this? So that is this one. You can also look at it from different perspectives. And you want to, so basically it's the same. You flatten it, okay? But if you look at it from the side, then you can see, okay, more. You can see more clearly the original objects. Now, for some of this file, I provide other information. Okay, so actually, I created a tutorial for this construction, so you can also have a look of this the production process later on. Now, so one page here, actually, if you look at the page, okay, so this is one page, one activity, contains some notes. I can write down some question here. This is the GeoGebra file. Okay. So there's a major, but apart from the file, you can also include other kinds of note, questions, or even image or videos to provide a complete activities, together with some other links as well. So these can be one activity, one activity page. Okay, now the rest, different topics. Okay, for example, advanced topics in calculus, or statistics, or matrix and transformations, okay? And then algebra, right? So this one is more about mostly about functions and graphs, or sometimes it also involves calculations. Right? I can also create some text for demonstrating or illustrating the calculation even with the steps. And then teaching. So this is a collection of teaching files. That means they are designed more for demonstrating or explaining certain teaching ideas. Okay? So that's why I put it under this group here. Okay? And then these are for just making patterns. Okay? So sometimes it is more about creation, right? Creating pictures or geometric patterns, right? And so you can see a variety of different things that you can do with the GeoGebra. And finally, some other miscellaneous files here. So here, this GeoGebra book is mainly trying to give you a sense of different kind of files that can be made and used. Okay, so it is a variety of different materials. Right? So of course, quite a long number of them can be quite complicated. I can't demonstrate today. Right? I'll go on to do something simpler to show you some basic tools and materials to try. Any question? Maybe I let you have a free trial first, and then see whether you have any questions before I move on to do some demonstrations of the making of some files.
Is it possible for us to upload our own images like this? It's very cute.
Oh yes, there's just pictures. Yes, when you create a file, there's an option for you to upload an image, and then you can do things further on manipulating the image.
It's very cute.
Obviously, you can't draw this directly with GeoGebra,
Yeah.
so there's an image to be important. So sometimes you can see different kind of image, right? For example, I think this one maybe. So you're trying this one, okay, right? So you can see some cartoon image. Okay,
Oh,
so you click and you can change. So these are imported image, okay? So of course you cannot draw it in GeoGebra, right? But if you have an image file, then you can include it in the GeoGebra file, right? Then it will be treated like an object that you can move around, enlarge it, reduce it, something like that. Okay? For example, another demonstration. This is the one I made. Now that is just an image that you find, all right, that as a file. But once you import into GeoGebra, then you can do different kind of manipulation. Now the transformation is based on the matrix, actually defined by the vector. Okay, so you can have a guess at how it works. Okay, right? But the rest are just mathematical manipulation. Understand, right? Even though I use some existing pictures, right, to start with. just give you some brief ideas if you would like to think about what it means. For example, this one is also an image. So the background is simply a photograph, right? That I can just input the whole thing and then fix it as a background. Right? But on top of this, then now I can investigate the spiral. So these are points, understand? So if you remove the background, then the whole thing is basically a curve at some points, okay? Of course, you have to think about how to define the curve, right? Actually, there's a function behind the curve to describe it, right? So provided that you can adjust the point A, B, okay? And you define the center, right? It need not be the origin, right? But the point is that if you have 3 points, A and B, okay? Anywhere you like to choose, and then you choose a point to be the center of dilation, okay? Can you generate a curve like this? Okay? But of course, it may not be exactly inside any of our school curriculum. It depends on which curriculum maybe you're teaching, okay? And in some cases, you may come across some kind of functions like this, okay? That you can describe. So the pictures is there as the background, right? To provide the context, right? Why we do it or how we do it. Right? So the curve is not too bad, right? But also depends on which point you sample. Can you see that? Okay? Not exactly the same. Right? Depends on which point you use it to generate the curve. So if you like, it can be an exploration. Try to think about it. Right? Does it mean that this Nautilus shell, this is called the Nautilus shell, right? Is it really in the form of a spiral, and what kind of spiral it is? Right? So we can think about this. Right? So this is already a kind of real mathematical exploration. You see that? So you get something from the real world, right? You see a picture, and then you think about it. Can it be described by a mathematical equation? Okay? And what kind of equation can it be? That would be the kind of question that students can also explore. So any other question you may have? Now we will try to experience, right, creating something, okay, inside the tool, okay? And now of course that can be for different purpose, all right? Now some of these files you can see that they are deliberately designed, right, for a certain teaching purpose, okay? So some may be mostly manipulated by the teacher inside the classroom for demonstration or initiate discussion. Because when I create an example, maybe I can also think of different kind of manipulation that can be done here, right, to instantly invite response from students. It can be questions about predicting anything, making a guess, or checking the result, describing things like this, right? So it involves a different kind of teaching and learning activities. Okay? And so later on, you can further think about it, how it can be used in the classroom, right? But for a simple case, maybe you, of course, at the beginning, maybe you simply try to get familiar of the platform or the environment to know what kind of things can be produced, right, and created, and so that you can further decide what you can do and what you can use inside the classroom. Okay? Now, how about, can you go back to the front page? So that you can open some of the apps, right, directly for some demonstration or creating the files together, if you like. Can you see this one? Okay. So I think the easiest starting point will be the graphing calculator, right? So this is a 3D graphing calculator, and then together later on you can also do some geometry as well, I think. Okay, so you can try it on your own. Maybe we open the graphing calculator. Is it okay? So if you open it, then you can see this is a blank page. So this is a blank page, with a graph paper on the right. And then also some region for you to input equations or any algebraic objects. Okay? So then you can see how it will be plotted on the graph, something like that. And there are a few tabs actually. This is the calculator. This looks like a calculator, right? And this one is called actually they call it a tool, but it's mainly for geometric constructions. Actually, you tap, then you will see another set of tools. Okay? Provided. And the final one is called a table. Okay? This is very new, right? So not too much to be used here, perhaps. But you can try later. So you go back to the algebra tab, then you can see spaces for you to input equation, coordinates, other kind of objects, or even commands. All right. Now, because in GeoGebra actually, basically all objects can be entered through a command. Right? So you can just type things. That's why some people assume that it looks like computer programming. Right? Because you can find a lot of different commands to do things directly through the keyboard. Right? But at the same time, they also allow you to construct tools with the mouse. Okay, on the key. So can you see this? Okay, okay. So these are tools that you can use with the mouse or the pad. Okay, so that you can directly create objects, particularly geometric objects, okay, on the screen as well. So either way you can do actually. Right? And so you can use the keyboard or the mouse as well. You can find out more. If you click on more, then you will see a longer list. Okay? If you click less, then you can go back to some basic ones. Okay? Okay, and so let's go back to the algebra tools. Okay? So let's see, we can input some equation. So the equations can be just write the ordinary way to write. Okay? For example, 2x minus 3y equals 10. Sorry. I think it's quite similar to many other graphing tools. Do you agree? I think you should have some experience, am I right? You're using some sort of graphing tools. Right? So nowadays, the graphing tools are very intuitive, actually. It's more or less like what you do on paper. And okay, now if you don't keep it, then you just delete it. It will be fine. Okay? If you want something more complicated, you can open the keyboard down there on the left. All right, can you see this? I open it again. Okay? Here, can you find it? Maybe I just enlarge it. Is it better? Okay, now I enlarge it. Okay, can you see it? So you can input through this one, all right, and you can find more symbols. Of course, you can just type using the keyboard as well for this kind of function, some of them. Right? Some may require, or maybe better, to use with the keyboard, with the specific keyboard provided. Okay? But I may not always use it. Right? I just show you a little bit. All right, let's do a parabola. All right. Now for a parabola, you can enter y equals x squared. Do you know how to press x squared?
The sign on the 6.
Yes. The cap, right? The cap symbol, and usually in the numeric pad set, the key 6. Okay. Or you can use the GeoGebra keyboard. Or you can square powers or roots. Right? You can use this one. Okay. But I think using a keyboard is also quite simple. Am I right? Okay. Now this is one way to input a parabola. So basically, this is a curve of an equation of two unknowns or two variables. Okay. But you can also enter it as a function. But can you see the difference? Maybe I enlarge a little bit. I do not press anything y. Right? I do not press the letter y. If now enter it, then it will add a function symbols there. They will name it as a function f. Okay? Or you can name it yourself. That means you can also provide functions, a name to it. Right? Or maybe x cubed, and then minus x squared. Now, maybe I repeat again. I press X and then use the cap, okay, in the keyboard so that I can enter the power. Right? If I continue, I will use the arrow key in the keyboard. Press so that, now do you know why? Because the cursor now is in the index. Okay? If you continue to press anything, to type anything, it will be maintained or kept in the index. Okay? But if I press the arrow key, then I will turn the cursor back onto the ordinary level, okay? So that I continue to type to something like this. Understand? If I press enter, then it's another function. Right? Just to let you know, so when you type an equation, you think about it, whether you treat it as an equation of two unknowns or variables, or you want to name it as a function. All right? Now, either way may serve, of course, different purposes. All right? So either way can be useful in some situations. Any questions about this? I think you can see the functions now, right? So that is the function. You can still move. Sorry, sorry, I cannot. Yes, I'm trying to get familiar with the mouse pad because I can drag inside it. All right. Now, in case I'm using the pad, I'm not too sure how you configure your keyboard or the touchpad. Okay. If I drag inside, then I can zoom in and out. Okay. But if I click somewhere here and then use another gesture, then I'm enlarging. I think I'm enlarging this part. So it depends on how you configure your pen. Right? Now, if you click on any one of this function, for example, this one, you can see some points may be suggested because they assume that you may be interested in these points. And you can also change the color. Now, when you click the object, you can change the color or the thickness to distinguish two different curves. Can you see the intersection? So they provide, by default, this is just designed by the author. All right? They assume that you may be interested in these lines. By the way, I have some minor grid here. I think when you look at the TV, you can see the minor grid. All right? But unfortunately, this projector cannot project the minor grid. You can change the grid anyway. You can modify, right? So you can decide how you like the grid, how you like the resolution of the grid. Similarly, you can press the other function G, okay? Then you can also see the other critical points on another function. Right? So they're also shown directly. So any questions about these?
I think I need to show the area between the curves.
Yes, I think you can do integration. Let me try. Okay, now can you see how I type? I type integrate. Now later on, you can check the command list, all right, to find out more what objects you can try. Sorry, not integrate, integral. Okay, so you can check the command list, but they also provide some help. Understand? Okay. Now, so this one, that means they already try to show you some relevant command. Okay. Can you guess? Perhaps you would like to do integral between functions f and g. Right? F comma g, start value, end value. I don't know what this Boolean value. You will have to check the tutorial later. Okay? I think you can try this one. Perhaps integral between. So I can just scroll down to check this first option. You see my mouse here? Right? Because I do not remember all the details of mine. Right? I just press something I guess will be relevant, then I will try to look up. Okay? So now I think I need F. The second function should be G. Right? Starting value, what I like, maybe 0. Just make it simple. And then the end value maybe 2. Okay, and let's see this. It fits quite well. Oh, good. All right, so you can color this. You can change the opacity. Okay, make it easier to read. And they also show you the area. You see this? This is the area. You can choose it. Now, this is the object. Understand? If I click the area, you can find it correspond to this object that I've input. This is the value already shown here. Okay? And then you can choose to decide whether you want. A normal choice anyway. I can hide the number, I think. Show labels, values. Can you see this option? Okay. Because A is the label, and the object is called A. So you can use the label for other calculations. For example, you can try to calculate another area B, and then you can type A minus B. Right? So you can use it for other calculation or other combine. Understand? So that's the labels of the object. And you can show the value. Right? Or you can take away the value, then you can just see the label. Right? Because maybe you want to hide it. For example, I want to hide it and ask the student what should be the area. Right? Instead of showing it, now you ask them what should be the area. Right, do you understand? Now, since you asked me for the integral, maybe I just further modify it. Okay. Now, let's say I want the starting point to be a number called A. No, A is already assigned. How about I call it maybe just C. Okay, C equals -1, for example. I can change it anytime I like. Okay. So that means C can be a number that I can change. Okay. Although the current value C equals -1, right? And then I can type another value which I like to be the end point. Okay. Now I would like to adjust the starting point and the end point. So let's call D. D equals let's say 2. Okay. So D can also be a number that you can modify anytime you like. Okay. You can change the end value, the starting and the end value actually. Now the integral, I go back to the integral. Can you see this? Can you see this? The integral, now I want it to integrate from C to D. Can you see the change here? This is the integral. Now, it is integral between f and g from C to D. The value is 2.25. Can you follow? Yeah. All right. Or you can look at the TV, actually it may be easier. Okay, now I changed the parameter. Okay. Do you see what I'm doing? Okay. So both the beginning and the end point can be adjusted by the slider. Okay. And you can also see the value change, actually. Do you understand? Okay. Yes? Have you typed this one? C and D are numbers only. They treat C and D as a function, but C and D are actually constant. Can you read my command? Is it clear? Okay. Because now my command is A is the area, right? A is the area or the integral actually. Right? It doesn't have to be A. You can call it anything you like. You can change the name actually. Okay. So anyway, this is the label. All right. It represents this object's integral between is the command. Between the two functions, f and g are the functions I have defined. C and D are the constants. okay? Or the parameters, because you can move it and change it. Okay? Understand? Do you use other solving graphing tools in similar ways? Not really. All right. Well, if you're interested, actually, I haven't planned too much of what to do. Okay? It just depends on the question. Since we talk about integral, I do something else. Okay? Can you follow me?
Yes.
Now, I want to put a point P here. You can just type a point without label it, okay? But I can also label it as a P. It's up to you. Okay, what is P? P is the coordinate. It's the point with the coordinate x coordinate c. C is the starting point, right? And I now take it as the x coordinate, and the y coordinate is a. Can you follow? It shows how the area, that means the integral, depends. Does it depend on c? Sorry, no. It should depend on d. I assume c is not changed, right? The starting point is fixed, but the boundary, okay, the right boundary is changed, right? So the area will be updated according to d. Understand? Can you follow? So I just type enter, then see what happens. I have a point here, the point P. Okay, so let's change D. Can you see the value of P? I can make it a cross, and then perhaps I change the color to maybe the purple one. Is it okay? Can you see this one? Okay. And now, can you follow? I can make it, okay, leave a trace. A trace here means that when I move or change the point, then you will see the path, right? How the point change. Okay. Okay. Now I move, so I can turn on. I have already turned on the trace. Okay. I move again. What do you see? What am I showing you? What do you see now? What's the purpose of doing this trace? So what's the purpose of making this trace?
Oh, fine. If this is the derivative, you find the original function.
Which one is the derivative? So you mean this function, okay, described by P,
Yeah.
okay, is considered as a derivative.
No, the derivative of the P is the other function, whatever it's integral with.
Okay.
Because the integration of that function.
Right. Yeah. So it depends on which one, right? You consider as the starting function, and whether you want to do the derivative or the integral. Okay. Don't worry, you can get back to some of this textbook knowledge later on. Right? But I don't know how you experience it in the textbook, right? Because this is also can give you an opportunity to revisit what you have learned in calculus in the textbooks. Actually, all right. I try to follow this path because I just follow something that I can see here on the screen, and then continue to think about it, how it can change, how it can vary. So basically, integral is about this area, the change of this area, right? So there's the integral function. All right. So the P, in fact, is directly demonstrating the integral functions, because it's telling you if this is starting point, and then you vary the boundary, then the area will be changing in this way. Will be varying in this way. Right? Then you can check where is the highest point. Right? What does it mean? How come is the sum of the lowest point, or where the zero means here? Something you can also think about it, right? Something like this. But anyway, this can be an integral function. Okay? And of course, you can also go back, even go back to the, now most of these things are still dynamic. I want to emphasize. What does it mean? You can also, for example, change this function too far away. Okay. Now, but the trace will not update it. I have to do a trace again. Right? So integral function change. You see this? All right. So all these are still dynamic. Understand? So you can adjust it anytime you like. Okay. And finally, I think this function. How can you describe this function? Let me see whether I have the symbols or not. I'm not sure. Ah, yes, I have the symbol. Let's try it. F, can I say F minus G? I don't know the syntax actually. I'm just playing around a little bit. There was some syntax error now. Okay. Let's see what we can do. Illegal function x. Can I type in the function? So how does it work then? Okay, let me try the calculus function. Function ahead, right? I try this one. Let's see whether it works or not. I'm not too familiar with this one actually. Let me try. F minus G. No, that's not work. Okay, forget it. Because I try to find out whether I can do the symbolic integration. Okay? Maybe I can have to use another app, the CAS. That's why I say that there's another app right here. Maybe it can show us the symbolic integral in some way. All right, let's forget it for the time being. I think that's enough for you to try. Okay. All right, so this will give you a trace of the change of the integral. That means actually this is the integral function by default. This is the graph of the integral function. Okay. So any questions about this? Yes.
My P is an error, not a point. How to change the setting?
This one?
Yeah.
How do you type it? Understand? I don't know what's problem.
It's a letter P. I
Okay.
cannot do.
Now, okay, I think I have to move on to another example. If you want to save it, now let me show you how to do it, okay? So you can save it. Of course, it depends on whether you have an account, all right? If you don't have an account, then probably you cannot save it now, okay? So you can keep this file, and you call it, for example, integral, okay? You can decide whether you want to be private, share, or public, okay? It's up to you. And then I save it. Then I will leave this file under my account in the platform, the GeoGebra 2. Understand? Okay. So if I leave it now, I think I can go back to the front page. I just click this label, the title, then I go back to the front page. And then I go to class resources and see my own resources. This is mine. And I can see this file edit. This now is the file edit. If I open it again, I can see this file. All right, and then I can continue to do something on it. Yeah? And I can also edit it. Now, can you follow me? I've already saved it in my account. So that they call it an activity, actually. It's not a file, they name it as an activity, right? Because you can still add other instructions, other links, other images or videos inside this page. Right? So you can add this activity. And now this is another layout. Okay? It is an activity page. Okay? You can add other elements. For example, you want to add some text, image, video, even another GeoGebra file. In one page, you can include more than one GeoGebra file, right? Or other web links or PDF files, something like this. So, and go back to this. This is the GeoGebra file, right? And you will put the mouse here at top, and you can see the tool to edit this file. Okay? So, but by edit here, it can mean add this the app pack itself. That means you can do some change inside, or simply change the size because it's now too large. Actually, okay, I will want to make it smaller a little bit. It may be much better, right? So I can change it to the, let's say, 100. And I can also allow the toolbar or the menu bar, something like this, or even the index and input bar or the style bar to be included. Or you can it's up to you. And then I hit done. Okay. Now, so that is the later editing that you can do, all right, on this page, including the applet itself. If you want to adjust the applet, you can do the same here. Or outside the applet, you can add other instructions, all right, do other things on this page. That is an activity page. All right. So I click done, and then save and close. You can add some text to remind you how to find the file, and something like this, or just save and close. Right, so can you follow me? So I have one page, right? And then this is much better because I make the size better now, right? On the screen. Okay. Then I can still see all the material here. I can still access the tool. In case I want to add anything. Okay. Or now, so if I edit it again, remember this list? You can open in an app, add this particular activity, or make a copy, right? Or further share it. Right? Now I edit it again. So this time I add a text above. I can drag it to the upper part, and then I type something. Okay? So this is an example showing Okay, so I can do some further editing here, or ask a question if you like. Okay, so this is so you can adjust it anytime you like. Right? So finish. So I further know. So I can decide when I want to further elaborate the activity or how I want to present it later on. Right? So a lot of things that you can further decide later. So I save or close again, so I can keep amending it or changing it. Right? Okay, so if I go back to the fun page and check my resources, on my own resources, okay, then I can see this activity, created and also edited. Okay? And later on, I can include it in some other books I like. For example, I may open a calculus, GeoGebra book, and then put all my files about calculus examples inside, or integration, something like that. All right. So you can now further decide how to gather your material, or even use folder. I can also use different folders to hold different material. For example, different topics. These are my folders. Yeah? So up to this, I can have this folder. Or simply just the resources. Okay. So, any questions? Can you follow? Yeah. Now let me try another example also for graphing, okay? And then show you maybe some other tools that you can create, some other materials that you can create in the graphic window. I open a new one now. Is it okay? This graphic calculator, I open a new one, like the previous one, right? Again, you can adjust the scale if you like. Now, by the way, the scale can be found here. If you tap on the right here, you can see the options for showing the grid, the axis, and then, or further down, you can change the setting. Okay? The setting here can mean the paper, the graphing paper. That means how do you like the x-axis or the y-axis? What do you like the scale? Okay? Or the grid. Do you want a finest grid or bigger grid? Okay? How would you like the line to be shown? Right? Or even the color. Right? It can be adjusted here. And also within this tab, can you see this one? Within this tab, you can also choose to modify the setting of other part of the screen. Now that is they call it algebra. Actually, it means this one. Right? Right. There's not much for you to adjust, in fact. But usually I like to display the object according to the object types instead of the construction order. Right? So that will make it more convenient for me. So you can also design it right, on your own. And also go back to the first button here. This is more general. They call it global. Okay? The general setting. You can turn it into other language if you like. For example, you can turn it into entirely simplified Chinese. All right. Or I just now switch back to English. Or you can play around with other languages if you like. It's good to learn language here actually. For example, I like Japanese. Then I can guess what this means. So do you know that in Japanese it's called kansu function?
Oh,
yeah. So you can practice with other languages if you like. Chinese, get back to English. Rounding, okay, so maybe sometimes you don't want too long, or maybe just shorter number. Okay, now finally, this one is quite important. Labeling, okay, sometimes it's quite annoying if they keep labeling new objects on the screen. So I like to turn it off, or just only label the points. Okay? I think it's much better if I don't have this. If I don't have this labeling for any new objects. So you can save this setting. That is for me because I have an account. So if I save the setting, then I don't have to do it again and again. Okay, now I do the parabola examples again. So I type the function, another function, x squared or anything you like. Okay? Okay, maybe just this one. Alright, so or you can type any quadratic functions you like. Okay? I just type any quadratic functions here. You understand? Now, tomorrow I will demonstrate another tool, the Desmos. Desmos is also a very useful and also very innovative, right, graphing tools. Right? And so you can do a lot of things in the Desmos graphing tools, or maybe even any other graphing tools that you like. Right? So for GeoGebra, some of the graphing tools may not be really so special or different from the other platform. Right? But one thing I particularly like GeoGebra is that in the graphing tools, you can continue to do a lot of geometric constructions. Now that usually may not be so easily available in other graphing. For example, Desmos may not allow you to directly create geometric objects on the screen. All right? I'll show you why I do so, of course, right? Maybe sometimes you think that what you need is just graph, equation, or coordinates, right? But in fact, it can be more than that, right? On the graphing screen, right? You can do a lot of things together. And that's why I like to highlight for GeoGebra, what's specific is that the graphing and the geometry are combined. Okay? But for other tools, usually may not be so easily related or integrated. Okay? So it can be some difference that you can try to pay attention to. Okay, now so what does it mean? Maybe now I add some points. Now, okay, now this is the geometry tool. Can you see that? Geometry section. So you now basically you can create a lot of things by using these buttons. But after finishing creating anything, go back to this arrow tool. Right? Otherwise, you will keep creating things. Very annoying again. All right. So try to make sure that when you're finished using the tool, go back to this one, the first one, this arrow, right? So that you are now manipulating or simply dragging objects around. All right. Right, now I want to add some points. Okay? So I use the point tool. Can you see this? Just add some point on the screen directly. So I don't have to type coordinates. Understand? Okay. Particularly, I want some movable point. Okay? So I just click on this. And nowadays, the platform will just create this button, this shortcuts to remind you when you're finished doing anything, go back to use the arrow tool. Okay? So that will give you a good reminder. All right, so let's try it. So I have chosen the point tools. Okay? If I point anywhere on the screen, this will be entirely free point. But if I put the point somewhere on the ground, you will see a difference. All right? Now I use the arrow tools again. Okay? Can you see that? If I go back to the arrow tool, the point A is freely movable on the screen. But the point B actually is stick to the ground. You understand? It is a point on the ground. So if you go back to the algebra window, then you can still see the coordinate updated. And if I move it. And if similarly, if you move the point B, you can also see it updated. Understand? But the point B, you can see the point A. You can see the coordinate. Point A is a free point. Okay? Point B is a point on the function, that means on the graph F. So this is the definition. Understand? This is the definition. Right? But you still see the coordinate of point B. Okay? This is the result when you drag the point B. Does it make sense? Now, this basic setup will allow you to maybe study some points on the graph. Right? You can do different things here on the graph.
So for the point on the graph, on the line, you just click the point on the line?
Yes, yes.
Why?
Now, of course, depends on how sensitive your pad or your mouse is. This can be the problem, right?
Yeah.
So you can see that somewhere here, you can see a finger. Right, and just click it, then it sticks to the graph already. Maybe you have to practice a little bit.
I see. I tried so many times I can point a point on the line. See, I try. I find
OK，就是你沿着幕不是，然后再动它。
Don't really need the axis, and you got axis to also attract the point.
可以放大点，然后放大，你找这个点，
哦
可能
Okay.
point， yeah。他们会给他手啊，知道，然后这里。What's wrong?
Oh my gosh. Wow.
啊，但是看这个手的不可以。对呀，我为什么放到这里，然后拿一只手出来？
Equation.
Oh.
Two variables. And it is an equation with two variables.
哦，我知道了，因为我没有把它变成一个方程式。对。
So you have to treat it as a function.
还没有确认这个。可以的，就是我一开始就
But I still assume that it will
然后
work,
按了 Enter， 它
even
没
it's a
有
curve.
方程，它就可以放上去。
Basically, it's a bit strange because I can't even pick your curve.
Just try this and say works.
Okay, let me experiment a little bit. If I type a function, a curve, see how it works. For example, I can pick an ellipse. Can you see what I'm typing? So now I type an ellipse and I add a point there. So I can't add a point on the curve. No. But this is not what I expect.
But when I change it to function, it works.
Okay, yeah.
Yeah, I can point.
Let me change the setting. I'm not too sure because I'm not too sure. I think in the past they still accept a curve, actually an object, to add a point on it. Maybe it's different now. Okay, so now we go back to the algebra window. To remember, I changed the setting here, right? So I have the objects. Remember, I used this one to change the setting. Okay. In the graphing, in the algebra views, if you choose this is the algebra view, right? This is the algebra view. And then I group the objects according to the object types. Okay? And that's why now I can see connects, the name is connect. This one is a function. Can you see a label here? Because I grouped all the objects according to the type. Okay? So you know that this is a function. These are points. And I can hide all the points. That is the reason why I like this layout. And this way, I like this way of presenting the objects. Okay? So I can hide, for example, if I think the point is not the focus, then I can just hide over there and just focus on the equations. And also this one, I can now delete it. Can you see this option? I can delete it. And you can also delete other points or just open a setting if you want to modify the objects, okay? Or in my case, I can delete the point. I delete all the 3 points, right? A, I delete the point A. I keep B and C. I delete the point D. Okay. So I have 2 points on the graph. I can add 1 more point again. Sorry, I think 2 points is enough for me. It's up to you, right? I think I just create this point, delete this point. Alright, so I have 2 points, A and B, on the quadratic graph. Can you follow? Right? Now you can see these circles, this mark here on the left. You can hide the objects or show the objects. Right? If you click somewhere under or near it, you are choosing the object and then do some editing. Okay? Now this is choosing the object, correct? This is hiding or showing. You understand? Understand the difference? Okay? Alright. Alright, now I want to do some further constructions on this graph. So this is not just a graph. That's why I say it's not simply a graphing tool. Alright? Because it's more than a graph here. I can now add the midpoint. If you scroll down down the list, I think you can see this. Okay. I don't know this one. Construct. If I have to open more. Sorry, here. Construct, yes, you're right. Construct, you can see midpoint. Right? If you can't find it, maybe you can open more. Open for more too. But construct, I think, is a simple tool. By the way, you can also see other common construction tools. Right? Midpoint, perpendicular line, perpendicular bisector, parallel line style. These are very important tools, actually. Angle bisector, right? Most of the geometric constructions are coming from this set of basic tools. Right? So you should bear in mind that actually these are very fundamental, right? Constructions for geometry. And sometimes even tangents, right, for higher or more advanced topics. And similarly, for lines, you can make segments or line or ray. That means one endpoint, right, and then extend it indefinitely. Circle, you can also have many options of drawing things related to circles. Okay, can you find this the midpoint tools? So once you click it, you can also see the reminder here, midpoint or center of something. Select 2 points, right? If you are going to do some constructions of a segment, then you can select a segment or simply the 2 points on the segment. Okay, so I now want to create the midpoint of A and B. Can you see this? So you can check it to check it, all right? So that is the midpoint between A and B. Right? So if you go back to the algebra view, you can now see the point C. So actually, I can take the command midpoint AB. That's the same, if you remember the command. All right? So you have 2 options, right? Either you do it more graphically or geometrically, or you are going here, just input the command, if you remember, or you can guess, then you can still get the object, the point C. C is defined as the midpoint of A and B. And then you can still see the coordinate at the same time. Understand? Okay, now the next thing I want to do is to add a line, vertical line through C to cut the curve. I want to locate a point on the function midway between A and B. Okay? I need the x coordinates midway between A and B. Okay? So I need a line vertical, but in this environment, I think the easiest way would be just to add a perpendicular line, not bisector. A perpendicular line, that means a line perpendicular to the x-axis, or a line parallel to the y-axis. It's up to you, right? So I want the perpendicular line, so it will tell you what to do. Okay? You can select the point, and then the line. All right? So by default, by definition, I mean for this construction, this is a line perpendicular to the x-axis and passing through the point C. Right? So you can check it again. So you can go back to the arrow key and then drag it and then to see it. And then in the graphic window, now you can see the point. I have now a line. A line is a perpendicular line, C perpendicular to x-axis, full C perpendicular to x-axis. Okay, and so the next thing I want to do is to add a point, which is the intersection. The shortcut here is just click directly at the intersection, then it will create a point. If not, then you can choose the intersect tool, right, to select the line and the function. Okay? But I think most of the time, if I just click on this directly, I can get the point. And if you go back to the algebra wheel, they will say that D is the intersection of FG. 1 here, I don't know what 1 means. I have to check the syntax later. I may not remember what that 1 represents. So you have this. You can see that D is always the point of the intersection. All right? Can you do it? Okay, the next thing I like to do is to create a triangle ABD. All right, maybe you can guess how to do it. I want a triangle ABD. I want to find the area of triangle ABD. So you may have to open more tools in order to see these options for polygons. Right? When you open more tools, then you can see a list of options, polygons, including even regular polygons. Right? But I think the basic one is already good enough, right, for most of the cases. Right? And down, further down, you can see options for circles as well. Right? So these are also very useful. So if I click the polygon tool, what I need is to just pick all the vertices that form the polygon. And remember, go back to the first one when you finish. That means in case of triangle, I put A, B, C, sorry, D. Okay, A, B, D. I don't need to point C actually. Okay, A, B, D, and click the A again in order to close it. Understand? So I click A, B, D, and then go back to A. Then they know, right? Now I have a polygon defined by A, B, D. All right? So do you know anything interesting about this triangle? Created this way? Now I can modify the lines a bit so that you can see more clearly. Maybe I change it to a dotted line and make it thin, or change the color. Okay. And then this is the area. Make it a little bit thick. Is it better? And I can also show the label and the values. Okay, it's called T1. In the tool here, you can change the label later on. And you go back to the algebra wheel, then you can see T1 is the polygon ABD. And the value here represents the area. Okay? The area is 5 point something. Now I set A at the point 0, -1. Maybe I move the point B to 4, 4, 3, okay? And then now the area is equal to 8. Can you see that? Is it easy to find the area of this triangle? Let me turn the point A, for example, to the point 1, -3. Now the area is equal to, what is it? 3.375, something like that. Okay, I move the point P a little bit upward. What is it? Move to point 5. Well, it's not that easy to adjust the point here, I think. I mean, to some convenience number. Okay. But maybe I change the setting a little bit now. Okay. I want to make the point A. Now I want to redefine the point A. Okay. So let me show you how to do it. Now, of course, by definition, I try to put the point A here, right? A point on the function f, right? So it is now stick to the function f. But I can redefine it to I set the parameter first. If I set h equal to something, just 2. I think I close all the segments. So now h will be another free number I can move around. Understand? I can also hide this line. Can you see clearly? Okay. So I can also show the point h, the values of h here. Okay. And then I now redefine the point A. I make it equal to h and f of h. Alright, so it's still a point on the graph. Can you see it? It is x coordinate is h, and the y coordinate is f of h. Okay? But at the same time, I want the point P to be a specific distance away from A. So I want this to be h plus 4, for example, or maybe plus 3 to make it easy. And then f of h plus 3. Can you understand? So I still make B another point on the graph, but I deliberately make it 3 units away from A, right, horizontally. Okay? So I can have now 11. So if I change A and B now, so B is keeping the same distance horizontally from A. Okay? And what is the area? What do you notice about the area? Can you see this? This is the area. So that's why I say that I can create this kind of geometric objects on the graph, right? Quite easily because of the GeoGebra tool. I provide both set of constructions and methods on the screen. So this kind of questions can be created quite easily. Right? Otherwise, you need a lot of coordinates and algebra commands to create it. Right? Otherwise, and I think this area is quite interesting, right? How do you find this area? In fact, if you want to further verify, okay, whether this calculation is correct or not, or y is not changed, something like that. How do you find the area of this triangle? Is it easy to find the areas of this triangle? Any suggestions?
To solve by hand. To solve the area by hand, or
And what do you do with paper and pencil? Yes, of course, you can have some method, right? But what methods come to your mind?
some kind of integration.
Some kind of integration to find the triangle's area? Is it easy?
It's not an
Not easy.
If we say CD is always the height of the triangle.
CD is not the height of the triangle, but CD is useful.
Yeah.
You understand my point here?
Right.
CD is useful, although it's not the height of the triangle. You can cut it down into two parts.
Yeah.
Okay? So that can be the base of one side and then the base of the other side. And you also already know that the distance here is kept, deliberately kept constant. Okay? So what matters is the length CD, which can be calculated relatively easy if you know the function, because it's just a quadratic function. Right? So you can still do it by, of course, you can still do it by paper and pencil, right? But it depends on what method you use. Right? Now let's check. How do you find the? Of course, you can calculate according to the function, right? According to do some algebra, or you can now turn to define it as k. K is a value defined to be the difference between C and D y coordinate. Okay? So I can do it this way. I can write down y of C means y coordinates of C. Can you follow this? Okay. Minus y coordinate of D. So that is the value k. I tell you this one, right? K equals y coordinates of C minus y coordinate of D is 2.25. And if you want to highlight it on the graph, you can add a segment, like this one. I now add a segment to highlight this. So you can see the length, and you can make it thick.
Why is k a constant?
Yeah.
And I can turn on the label and turn on the values. Okay. Now it may not consistent because I is the label of this segment. It's not k. Okay. Because in my calculation I say k is defined as the value, right? But this I is the name of the segment. Right? But if you really want to make it better, you can open the setting and then define the caption. Okay? You can say k. Now k is the caption. That means it's anything you like actually. Okay? Or you can say the length. You can type in a number here. And then change this to caption and values. Then it will show the caption. Right? So the caption, in fact, it can be anything you want to type, right, or to show here. It is independent of the name of the object itself. The name is still I, right, for this segment. Right? But what's shown on the screen is the length is 2.25. Right? So now you can see the length. And when I drag the H, so this segment is not changed actually. Yeah. Okay. So now you know a little bit more, right, why the areas of triangle is not changed. So the key is actually the length here. how do you calculate the length. But I think it's relatively not so difficult. If you go back to the formula of the function, and you can do some algebra, right, to check it. So it's still manageable, right, for the students, am I right? This problem, now you can see that I put quite a lot of geometric construction in this graphic window in order to discuss this problem. Okay? I'll show this problem. So finally, if you want to demonstrate visually, okay, the length is not changed, you can remember the trace option. This is the trace option. Okay? So if you open it, then you can see. I don't know how convincing it is. Because some students still may not realize the length does not change. Okay? Right? You can use a ruler to come out and then right, to verify that the length is not changed. Right? And then another demonstration more visual. Right, understand? So this is what you can do. Now I just quickly pick up this problem from our IB textbook, right, from last week. If you're interested, that is extracted from the IB textbook. Right? I think analysis and interpretation, AI, right? AI high level. Okay? So it's page 451. Right? So that's the investigation about triangles, right, within the parabola. So you lead to some further discussions and questions about it. Right? So you can check it later and see how you can be used to demonstrate or to discuss this problem with the students. But of course, I think the purpose of the GeoGebra file here is not simply give them the answer, but to show them bit by bit, different elements, different aspects, or try to encourage them to observe or to describe what's going on, how they relate the different parts together, okay, and come up with some suggestions. And all these are combined together, right, in the teaching design course. Okay, it's not simply because I demonstrate directly the answer to the student. Okay, so do you have any questions about these examples? So I can save these examples again. So that, or I can make it smaller first. I don't know whether it's better or not. I mean, I don't want to adjust the size later on. I can save this file. So I think it's saved in my account, perhaps. Yes, it should be this one. Okay, so it's open now. Now I have a tool, new files made. This is the two files I just made today. Okay? So you need a very short break before I move on to another example.
电
对
池。
中国的哦，是高考上来的。
你可以让你的学生参与到。Why it means automatic?
Oh, and by default, it's designed this way. So if you just click on this and move slowly and then release it, and it will just continue to spin.
Oh,
It's
wow.
just the design of the software.
You can write by yourself the move.
No, I think now basically it's just the change of wheels, right? Because any object here, you can always use the mouse to change the wheels. Okay? But once you release it, sometimes so they continue to spin. And still you just click it stably. Right? You just drag and then release it, and it will hold. Right? But if you turn a little bit and then release it, and they will just continue to spin. So it's a matter of the gesture, and it's,
刚刚是在 A 和 B 之间加一个函数什么函数？但是它也要根据那个设置。哦，它保持了。对。是不变的，它没有设置。对，它是把它就是道歉说明打上去。对，可以等于 1c 减 1d。然后 c 会变在这里。对，然后他们站在这个距离上。那你刚刚说要设定它是 A 和 B 之间好像有个固定的关系。是吗？没有吧？为什么需要固定的关系？它不就是一条线吗？因为如果 A、B 是两个任意的，就是你 A 动 B 跟它动，对吗？你动一个点，因为有关系才会动。因为是随机的点。 就是控制这个 A 动的。
因为 A 是 H 控制的，
对，
然后 P 也是 H 控制的。
对，对，就是这个函数。
是什么呀？就是刚刚
A B 之间的距离是3。
是这个。
就是这个函数。A B 的方向距离是3。然后3是底乘，对，底乘。
为什么它要加3？因为它是对应的。为什么它
这个3是它自己设的。